everyone, and thanks for joining. My name is Tracy Cook, and I'm the online media manager for ModernAnalyst.com, the premier community for business analysts. I'd like to welcome you to today's webinar entitled A New Look at Data Modeling and Data Analysis. Today's webinar will last approximately 60 minutes, including the question and answer session at the end. Please be sure to submit your questions in advance using the questions feature of the GoToWebinar software. Today's featured speaker is Steve Blaze, PMP, PMI, PBA, author, consultant, teacher, and coach. Steve has over 55 years of experience in information technologies. Steve, welcome.
Thank you, Tracy. We're going to talk about how data modeling has changed over the years and what we're doing right now with data modeling, if anything, we're doing. So let's look at what traditional data modeling is all about. And it kind of gives you the elevator pitch on data modeling. If you've already done data modeling, that's fine. Otherwise, this may be an introduction. I had a friend who took a master's class in business analysis. And we worked together on several business analysis exercises. And she took 2 full semesters as part of her overall bachelor's and master's program in business analysis, and the two semesters of data modeling, and learned all about data modeling. And she kept mentioning, we'd talk, and I'm a big data modeler from long before I was a business analyst. I was a systems analyst back in the 60s and 70s. When data modeling first started, I loved it. And so I'm, big on data modeling. And she said that in the about 8 or 10 years that she had been in the business analyst business at the time we were working together, she said that in the whole time, she had never once had to use data modeling. And yet, she spent 2 full semesters learning data modeling to be a business analyst, but never used it. So the question is, what's data modeling all about if business analysts don't actually use it? And it's true, because I have talked to hundreds, maybe thousands of business analysts over the past 20, 25 years, and very few worked with data modeling on a full-time basis. One place where I worked, every single business analyst knew data modeling because they had a data model of the system they were working on their wall, but they never did anything with it. It was just there for them to see. Nicely rendered, multicolored, really neat picture of the data model of the system they were working on, but they didn't touch it. Why? Because they had database administrators who handled all of that. So what is a traditional data model? A visual representation of the data for any given information system. In fact, it doesn't have to be an information system. It's just a visual representation of data. It provides an illustration of the types of data used and the connections between that data. It looks like this. Now, this is your elevator pitch about data modeling. And if you haven't done it, this is not intended to make you an expert on it. And if you have, it's a refresher. So those boxes, those rectangles that you see that are labeled, are entities or classes. They're entities in the data entity relationship diagram, and they're classes in the class diagram. And that makes sense. That's what they're called, right? Now, the second thing we need to know about it is the attributes. Now, the attributes in an entity relationship diagram represent fields. In a class diagram, they typically represent columns. So fields from non-object-oriented, non-relational, and columns. Most of you are familiar using rows and columns in a relational database. Now, the entities and classes describe containers or descriptions of data. So you have an employee. That's a container. That's a class of employee, of person. And that person happens to be an employee. The attributes then define what makes up an employee. So you've got an employee ID, you've got a date of work start, you've got a salary, hourly rate, address, phone number, dependents, and so forth. Those all together create a unique employee, only one of a kind that has all of those particular attributes. And it doesn't matter whether you're in a class diagram or a entity relationship diagram, they're still going to be the same. They define what the entity or the class is all about. Now, the third thing that you have in the entity relationship diagram is the relationship. In the entity relationship diagram, the connection between the two entities is called a relationship. In a class diagram, it's called an association. What constitutes the dependency, the one-to-many that you may have heard about, in entity relationship diagrams is called your cardinality and optionality. In class diagrams, it's called multiplicity. And there it is. Those are data models. Now, I have another model that I wanted to show you, which was a snowflake diagram from data warehousing. In data warehousing, we have diagrams which really model the architecture, but they're the same thing. There's boxes, rectangles that represent entities, and there are the words within the box which represent attributes. Same thing. Primarily, you want to remember that this is structure. It's not the data itself, it structures the data. And as a result, it can only work with structured data. So, how do you usually do an entity relationship model? And this is where you say, well, yeah, business analysts kind of do this kind of stuff. Well, why don't you do it anymore? We're going to define the problem and solution. That makes sense. That's what the first thing a business analyst is supposed to do, is define the problem and then eventually define the solution. We're going to gather information. Well, yeah, we go talk to people, we have interviews, we have group sessions, and we get data about the problem domain. We then identify entities. Where are those repositories of data? Where are the classes of data? There's the organization, there are departments, and there are customers and suppliers and inventory items. What are the items in the data that I want to worry about in this particular problem domain that pertain to this particular problem? Then, once I've got the entities, I'm going to identify the attributes for those entities. And then to identify the relationships. Now I can do these in reverse order. I can identify the relationship, then the attributes. Usually I do them all at the same time. Now I have the entities, attributes, and relationships. I can draw the diagrams, and then I can reconfirm. Here's what we have. Did I get it right? Does this information relate to that particular entity? What other things do we have to know about an employee? What other things do we have to know about an inventory item? And we review it with the customers, the consumers, the users, the solution team, not just one, but a whole bunch of people, because the solution team has to look at the model and say, yeah, we can do that. Yeah, we can work with that. We can't work with as many-to-many relationships. Can you break it down, decompose it into two one-to-many relationships? No problem. Got you covered. So we're going to, as it said, that the primary purpose of the entity relationship diagram or the class diagram is communication. Talk about what we have, what we're doing. Then, of course, the key element of entity relationship modeling, data modeling itself, whether you're modeling for a data warehouse or you're modeling for a data lake or you're modeling object-oriented, you're going to do analysis. Now, this is when, as a business analyst, I've done data models probably because of my background of 20 years in data modeling before I even started with business analysis. But as I say, most business analysts don't do this, except that a lot of the information that's in the data model is done by analysis. It's stuff that you do day in, day out. You analyze the business's data so you can find out what the entities are. You analyze the domain to find out which ones are pertinent. You analyze the relationships between the data in real life so you can represent them as accurately as you can in the model, allowing for the fact that some things in real life can't be modeled. We want to analyze those business rules. You can have an invoice that can be paid by a payment. However, one invoice might need multiple payments to complete it. A payment might pay off multiple invoices. A payment might pay off 2 or 3 invoices and part of another invoice. This is all reality. This is all what we have to model so that the developers, the solution team, can write the code to do that. We're going to analyze the data over time. Gee, this is an accumulative field. And right now we have 118 employees, and we're growing at a rate of 57% a year. Therefore, in this number of years, we're not going to only have 3 digits to define the number of employees. We need 4. We're going to evaluate the content so we know the format. It's going to be a number with dollars and cents, and we're going to take it to 3 decimal points so we can round up. So we have 4.3 as our format, and when we mask it to print it out, we're only going to show 2 of those decimal points. We also want to look at the overall usage. Who can access this data? Okay, everybody in the organization can access the entire HR file on any individual employee. Your entire file that constitutes payroll, except you can't access any fields relating to what the person gets paid, the bonuses, how often they get promoted, what their rating is by their supervisors, etc. So part of that table can be seen, but the other part can't. That's the type of thing that we come up with through analysis. So we want all of this stuff. Working with the data models, it's all about analysis. So why do we do it? Well, it's pretty much kind of what we've been talking about. It's an excellent, you can't beat this form of data organization. As you'll see here coming up in a page or two, we have data models all over the place because they organize the data for us, put things in place, connect the dots well. It provides that blueprint, especially if you're a data-driven organization. It's all about that. You have a corporate data model. I spent, about 9 or 10 months in Herndon, Virginia, working with the Fannie Mae, and they had a corporate data model. And we were taking the corporate data model and converting it into a corporate object model. It's a very interesting and challenging project that we were working on. But it was really neat to see the corporate data model already there. They had been using it for a long time. And when they made changes to their systems, it was a whole lot easier. Everybody knew where the data was. Data only appeared once, write once, read once, write many times. And of course, it establishes your roadmap for adding new data here and even new tables there. So it's a really good thing to do. So why aren't we doing it? We business analysts, it consists of a lot of analysis, and look at all the good things we do. Well, let's look at it. For one thing, it's not really a good communications tool for business stakeholders. At one particular client I had, a telecommunications company back in the days of WorldCom, we were doing their Canadian billing system, and management, they were building a data model first, primarily because the tool we were using, a 5GL tool, used the data model. It worked everything off the data model. Very forward thinking. And in fact, that tool we were using was made by Cognos, people who now do the business modeling stuff and the analytics. So the management said, hey, Steve, I want your people to show the data model to the users. And we had a selection of users who were representing the full complement of users. And so we had a meeting. I wasn't that excited about doing it, but okay. And we had a meeting, and we all met in the room and put the data model already up on the whiteboard. Here's the data model. And things were going well for the first 4 or 5 minutes, and they understood. But then we got to the payment. I mentioned, one payment can pay many invoices. One invoice can be paid by many payments. Many-to-many relationship, not allowed in relational databases. So we had a keys-only file that provided a one-to-many relationship in both directions. And that was cool. We understood it. That was great. Except when we explained it to the users, they kind of objected. We don't have such a thing. All of the entities we showed them is a customer. They do, yeah, the customer. I can talk and feel a customer, an employee. Yeah, we are an employee. I can, I know that. An invoice. Yes, there's a printed invoice. We got one of those. But when it came to that, I think we called it INV pay or something, just made up a term. They didn't understand that, and so we had to try to explain how you could not use a many-to-many relationship. For the next 40 minutes of the hour that we had allocated, we spent trying to explain basically a data modeling class. We never did complete the model. We never did get a yes or no. And the end result was they lost quite a bit of trust in us because we were trying to explain things they didn't understand, which meant we were kind of doing, computer stuff, create a black hole and say magic happens here. Wasn't a good experience. And we found that for the most part, it's very difficult to explain the intricacies of data modeling to a business stakeholder so that they understand what we're doing. And so we just don't do it. And because business analysts have to be communicating with all of the users and the business stakeholders and the management as transparently as possible, this data modeling doesn't work for that. And it doesn't really create itself to creating business requirements. You look at a data model you can't come up with. If you have a data flow diagram or an activity diagram, even a state chart, those are fairly easy to translate those into requirements. So easily, in fact, that there are tools that will do it automatically. Data modeling? No, doesn't work. And the most important reason right now, today, 2023, if that is the year, yeah, it's 2023, almost of the data has stabilized. The data modeling was primarily for transactional systems. And most of the transactional systems are there. They're stable. We're not building a brand new accounts payable system. We're not building a brand new anything that is strictly nothing more than transactional. So we're not building new data models. The primary reason is that it's not our job anymore. Data modeling is really now part of database administration. Ultimately, all design, data design, is redesign. We're not really doing any new stuff here in transactions. Data modeling is owned, as I said, by the database administrators. And I mentioned that one, they had the model on their wall, and every once in a while, I was there for 6-8 months, and during that time, I think they changed the model twice during that time. And the DBA sent out a notice, hey, we're going to be, we got a new model as of this date. And as of that date, everybody got a new copy, put it up on the wall. Now, it wasn't that they put it up there and put it in a frame, up next to the picture of the Washington Monument or something. They had people were marking it up, and it was used, which pleased me, of course. Data modeling is static. It doesn't change a lot, but it's a great reference. It's more associated nowadays with legacy systems. I run into this constantly. We talk about data modeling. Yeah, the guys over there working on the COBOL systems, they got data models. We don't do that here in working in Python. Data models are necessary. I can't imagine any kind of system that doesn't have a data model. Data modeling itself, that's not as necessary because we're really making only small improvements, and those small improvements that refine the data model generally produce very small improvements in the overall systems. That's the way data modeling is today. So, what are we thinking about when we think about data today as business analysts? Well, they're thinking about how am I going to use big data? Now they want you to use big data. They got big data. How am I going to do that? How does that affect the systems that I'm already working on? How does that affect the new assignment I have? Management wants some projections. They want to know which product has the best chance of success. Now, how am I going to go about telling them that? They come to me as a business analyst because it is analyzing the business to tell them the answer. That's where it's strictly an analysis process, even though it's called analytics. I am not a business analyst, I'm a business analyst, but it still sounds the same to management. Manufacturer wants to know why there are issues out there. We got 14 years of manufacturing data that show all sorts of different ups and downs. And they want to know what's going on today and why this is happening. And they want us to go through all of that data and be able to trend it for them. Well, even when you're getting into software development, how can we best lay out our user stories in the most effective, efficient manner so that we are using the user stories and putting them in order? After all, user stories are independent, right? They're not supposed to be dependent on any other user story, but there's got to be a way of doing it. And really, when you're talking about data, the most important, the biggest issue that's on business analysts' minds right now is machine learning and artificial intelligence going to take my job away? Am I going to lose my job if the company goes full data? If I don't become a data analyst or a data scientist, am I going to be out of work? Or do I have to find someplace else to work? Well, I can't answer that last question, but let's look at the others. There is us today. There is us. That's the way it's been since 1968 when I started out. Now, we've added in a whole bunch of other stuff. On the left-hand side is our transactional processing. There's our inventory and finance and marketing and sales and order entry and all of that. We got all sorts of data out there, and we've got the whole data models out there to drive that. And then we take all of that data, back in the 90s, we started taking that data and running it through a process called ETL. And many of you may, if you were around that long, I certainly was, involved in defining the requirements and working with the data to produce the data for the data warehouse. Now, over on the right-hand side, the left-hand side would be your OLTP, online transaction processing. Over here, this is all analytics, online analytics processing. User interfaces, your business objectives, Cognos, MicroStrategy, and so forth, and data mining, out there getting all that data from the data warehouse. But that's not enough. We haven't stopped yet. We need more data. Why do we need more data? Well, because there's more data that we can get. Data from outside the organization, streaming it in from Facebook, from Twitter, from Instagram, popping it into a data lake as a temporary repository. We're bringing in emails and phone calls and audio and streaming video. We got security systems that now take all of the streaming video from all the cameras and feed them through and identify any anomalies. And that data can go into an external data repository and then go through ETL and become part of the data warehouse. We got software that'll take stuff out of the data lake and put it down into the data warehouse. And we've got software that will go directly to the data lake. By that I mean, in the data lake, we have unstructured data, streaming video, streaming audio, emails, photographs, all sorts of data that does not fit into the data warehouse, does not fit into our transactional data stores, because those are all structured. Now we have unstructured data. Think of the things we can do. So where is all the data modeling? Well, the one I mentioned is over here on the left-hand side, data model. There it is. All of the stuff that drives the online transaction processing is all in the data model. But we also have data models for the data warehouse. I mentioned the star and the snowflake architectures. There are diagrams to define the star and snowflake architectures, again, so that we know where the data is so that we can pull it off. Also, kind of a part of the data mining and all of those software tools, the business objects and the Cognos and MicroStrategy and all, they all have their own little data modeling to create the information cubes, the three-dimensional cubes, so we can slice the data and dice the data and pop it into great data visualizations and graphs and charts and so forth. And yes, even up there in the good old data lake, I really shouldn't say good old because it's not that old, is a data model. Most of these are fledgling. Most of these have just started to get going. They're not standardized. They're not structured as yet. They're ways that people are using that throw out, hey, we can create the data model so we know what we have there. When we want it, we know where it is, what we can do to access it, what the keys are, and so forth. So there are models there. Again, it's kind of finite and all kind of structured. So that's what we have now in the organization. But even all of that still puts you back in the database administration world. Well, as you can see, kind of creeped up there on the right-hand side, there's another data model. And that's the data model we're going to talk about right now. Right in the middle of data mining is a data model. And it's not a set of diagrams. It is this process. The whole process is about creating a data model. Now let's take a quick look at this process. Now this process is what is called the CRISP DM, and it's a standard process put out by an organization, a standards organization, and the CRISP stands. I don't remember what the CRISP stands for. The DM is data mining, and this is the model that we follow. I've seen variations of this and done variations of this, but basically they come down to this. First place, we want to understand the business. What is the business problem? What question needs answering? If we're going to do analytics, we have a question to answer. How do I know what the big selling movie is going to be in 2025? Or 2026, actually, because it takes a couple of years to make a movie. So I want to make a movie. I want to know whether I should make a Western, a horror movie, a romance, comedy, what's going to be big? Who are the stars that are going to be big I can put in it? Because I want to get a big sale, a big movie. I want to be the movie of the year in 26. How do I know that? Well, that's a question. And yes, we can go and get the data to answer that question. So the next thing to know is, where can I get that data? What data do I need? What data can I get? And at this point, in the past, if we were faced with this problem, we would look at the structured data that we have. We were limited. We could only go so far. We certainly can't say, well, let's get clips of all the movies that have ever run and see how they're flowing. Let's find out what the most popular movies were in the past 20 years, and let's run an analysis on the films. We say, no, I can't do this. We don't have data. They can't fit into a database. But now we can, because we have the data lake. We have unstructured data that we can use. So once we have the data defined, then we're going to prepare the data. We're going to extract it, clean it. Remember ETL? Yeah, similar to that. We're going to take the data, the streams in. We're going to extract the data we need. We're going to get the data from our own data warehouse, from our own transactional files, from the data lake. Find out that we aren't getting it right now, but it's out there. It's on blogs. So let's stream it off the blogs. How do we get that data? We can buy it. We can rent it. But once we do, we have to clean it. We have to ensure its reliability, accuracy. Once we have that done, and that right there is about 60 to 70% of the entire job of the data model, then we actually devise the model. Basically, from our perspective, we're creating an experiment in which we know what the results are because we know what the data is, what we're going to use. We call it a training set of data. Once we do that, the model is created. Then we're going to test that model out to see if, in fact, it met what our expected results. If not, we go back again. And this is an iterative cycle that goes through until a point at which the model tells us exactly what we expect it to do. Then we get a larger test set of data, run it against a test set of data, and see if it mathematically is within the range. It looks like it's working. At that point, we run it out to all the data in the world. We're going to put it into production as needed. Put it on a dashboard. Do it once to find out. this is the kind of movie you should do in 2026. All of that is to produce the data model. You say, well, okay, yeah, but can you break that down for me, Steve, from a business analyst perspective? I mean, we're not talking about diagrams anymore, right? Exactly. So let's look at it and find out that with data modeling, this kind of data model that we're creating is not that far removed from what we're doing now. We just have to change our mindset a bit. So we're going to conduct an information gathering sessions to gather the information about the business. We're going to analyze the problem domain. Oh, that sounds familiar. We're going to determine what the real problem is. Well, that's our job. Then we're going to look at the data. There it is, coming up there. We're going to not just look at the data that's given to us. We're going to do this. We're going to review all sources of data. Let our imaginations go wild. What else would we need to know to determine what the best-selling movie is going to be in 2026? We want to analyze those data sources to extract the relevant information, identify other sources of information as needed, and again, all sources, video, audio. Get the critics who do their webinars, their podcasts, and so forth. We want to pull those up, see how many times a certain kind of movie is mentioned, and we want to then find out how we're going to get that data to bring it in and where we're going to put it. We would be defining the requirements for software to be written to extract all of that data. Then we're going to again be looking at requirements. After all, many business analysts say their whole job is about requirements. We're going to determine the accuracy, currency, and relevancy of the data, the quality part of the data, and define the requirements for making that data accurate, current, and relevant. Now we've got that data. That's a lot of work, but there's nothing in there. You look at that and say, gee, I can do that. I'm doing that now. All I have to do is expand my thinking to wider ranges of data. Then we get into the modeling. You say, okay, well, not much we're going to do here. I mean, it's like the software. You define the software, and once you turn it over to the developers, kind of your job is done until they finish and you can get involved with the testing. But if you think about it, at least in my case, the developers always have questions. What about this and what about that? And gee, we can't do it this way that you asked for. Can we do it this way? Do you think the users will allow us to do this? Do you think the users will like it if we did this? And so we're going to have the same thing here. We're going to work with the data analysts and data scientists, answering their questions, running interference with the business, and so forth. Then when we get to the evaluation, we're going to evaluate. Now, the data scientists and data analysts are going to be evaluating. They're going to be checking and they're running mathematics and they're going to be seeing and they're making adjustments to the data, making adjustments to the model. What our job is to look at the results as it pertains to the business. Are these results what the business can use? So we're adding that layer to the overall evaluation. And we're very much involved with that. As it goes round and round, we're evaluating it. And in the end, we're going to determine what is the best way of showing this data, showing the results. A graph, a chart, pie chart, bar graph, scatter graph. And we're going to determine what the best data visualization is going to be. Whether we actually produce the data visualization or not, we're going to be making the decision of which of the data visualizations to use. And we're also going to define, not necessarily design, the best way of doing an ongoing, not a one-off type of situation, but something that's going to keep coming up every month that shows you, it produces the next level. So we're going to decide whether it's going to be a dashboard, whether it's going to be a set of reports, whether it's going to be a playbook. How are we going to do this on an ongoing basis? And if it is a dashboard, how are we going to show it? Dial, thermostat, announcements, alerts. All of this is about creating that data model right there. So you can see And then once, of course, it's deployed, then we go back into the business again because things will change as a result of having this new information in a new way. People will be asking for more, and it's keeps going round and round. So rather than producing a data modeling, saying, there it is, we got it signed off, put it on the wall, we're good to go, we continually revise and refine that model for various different reasons, such as to filter large amounts of data to determine what is really happening. This is called descriptive analytics. Recall the request to find out what's going on in the manufacturing, 17 years of data, manufacturing data out there. We can't do that. Oh, well, yeah, we could. You know, a small army of business analysts sitting in a big room and going through all that data. But we better to have the model do it for you. We want to get a reasonable idea of the future. What's on stock? What is going to be the best movie to happen in 2026? And that's called predictive analytics. We want to figure out. Now the manufacturer said, hey, okay, you can tell me this, but tell me why. Don't just tell me that this is happening in manufacturing. Can you explain to me why it happened? And yes, we can do that too with the analytics. As a business analyst, we should be able to come up with the reason why. Give the model the direction for coming up with a reason why it happened, a diagnosis. And this is called diagnostic analytics. We also want to determine what we want to do. Okay, now you told me what was wrong. The reason why we had that drop in manufacturing was because of the weather. And so every time we get a certain kind of weather, there's going to be a drop in productivity. Well, what can you do about it? Well, there are answers. In fact, IBM and EMC and others have devised ways of machines correcting themselves. And how do they do that? They use prescriptive analytics. And no longer on the horizon, but still kind of a new entry into the analytics world is behavioral analytics. We're looking for anomalistic behavior. An employee is obviously looking from a security perspective, looking for employees who are acting not quite the way they should, who might be engaged in fraud or other malevolent activities, and customers. Yeah, customers are suddenly leaving in droves. Why? What is the behavior that's going? What's causing that behavior? This is what we're using these data models for. Any one of these or a combination of. So here is an example. Now, I've used, in this case, fraud from our side. Now, you may have, at some point over the past 4, 5, 6, 10 years, you may have gotten a message from your local credit card company saying, we noticed that you charged something in San Francisco, and we also noticed that you are living in Florida. So we were just checking to make sure that was in fact you who charged in San Francisco. You say, yeah, I took a trip out there to see my sister, and I charged some things while I was out there and came back, and I was only out there for 2 days. Good. It's not a fraud. What they're using is predictive analytics, descriptive analytics, and behavioral analytics to determine whether you are doing your credit card is doing something out of the ordinary, and then they're going to let you know that it's out of the ordinary because it most likely is a fraud. I've been notified by my credit card companies several times. Yeah, it happens 2 or 3 times a year, in fact, where there'll be a charge someplace else. Say, no, that wasn't me. And they take care of it immediately. Don't worry, it's not going to cost you a penny. We've got it covered. That's analytics at work. Well, this is fraud from the other side. Suppose you wanted to find out if there's a fraud going on or somebody trying to hack into your system or something based on their behavior. Now, all of that on the previous page produces this, which kind of looks like a brain there. That is our model. Then from here, what's going to happen is we're going to take all the data in the world, quote unquote, not really all the data in the world, but from all the activities that we have access to, and the model is going to produce a nice big list of all of the potential frauds, all the things that says, based on the information you gave me, here are the frauds. Now, we know what the frauds are in this particular set of data. We're just making sure that the model does too. So it comes out, gives us that list, and that's where the analyst comes in. The analyst looks through the list and says, okay, there should be 17 episodes of fraud here, and I only counted 13 that the data model created, so it missed 4. So we identify the 4 it missed, and it produced 2 that weren't really frauds. So we identify those. And we feed that back into the model. Okay? Back into the model, which then does it again. It corrects the model, and then we go through it again. Whoop, come back. We go through it again with the new data, with the new code, and it produces 17 frauds, 3 of them wrong, 2 of them right. We do it again, and we continue this until it's got the exact number that we expect. At which point, then we can get a wider amount of data and do it again. Eventually, still needing a little bit of human intervention, checking it, but eventually the data model will find all the frauds in all the data passing through the systems. Now, just as a sidelight, that's a lot of work, right? That's a lot of manual work. And after all, the analyst could miss one, could misread something, could mistype something. So there's human error that's possible to cause this thing not to be quite correct. So eventually, we can use machine learning. And you see that little round thing there in the bottom where the first red arrow goes to? That will move up and replace the analyst so that the model that we create in conjunction with the data scientists and the data analysts and everybody, that model will correct itself. Prescriptive analytics. It will look against the data it's supposed to have and find out what it has that was supposed to be there, what it has that isn't supposed to be there, and make the appropriate connections and keep going around itself. We don't have to be in there doing it ourselves. That's the magic of machine learning. Now, let me do one here. Show you how. You say, well, yes, Steve, that's cool, but that's a lot of technical stuff going on, right? And there's a lot of coding and specialist stuff, and after we get the model, there's nothing for me. I mean, how do I define a model? I don't know Python. I don't know PHP. I don't know that stuff. Well, let me show you, because we're not really writing the code. We're going to create the model for the data scientists to polish up their R language and get in there and write it. So let's look at a real one from a company that was dealing with an issue, something that you might be familiar with, an internal issue, and something you really wouldn't think that you could put into a system. Here's the problem. They found that they were having a lot of conflict in meetings. They'd have a meeting and there would be conflict. And the meetings were ending in conflict and not being very productive. And a lot of arguing about a particular subject and destructive conflict going on, and they were not getting what they meant to accomplish in the meeting. So they're wasting a lot of time. Well, that wasn't as important. Obviously, it would be important. I mean, you don't want to go to meetings and just watch 2 people argue. What was really damaging was that people were not going to meetings anymore. That was bad. They didn't want to go to a meeting and just sit there and watch people fight, especially people that are introverts who don't want to even see that kind of stuff. And the conflict was coming out of the meetings. They didn't leave it in the conference room. The conflict came out. It started in the conference room and expanded. So the company wanted to do something about that. Now, I put it to you. Is this something in your mind you could say, oh, yeah, we can create something that would stop that. We could figure out why and figure out a way of stopping it. Now you probably think, well, I need some psychologists and some social people, sociologists, and that kind of cognitive behaviorists. Let's look at what the business analyst came up with. This is just one aspect. Okay, they came up with this problem statement: we don't have successful meetings because of the continuing conflict in the meetings. Right? That's a statement. Again, what do you do about it? I mean, sounds like something a business analyst would be involved with. Here is their model. We're going to record or access recordings of meetings. So we're going to start off with audio, streaming audio, or using text. Somebody takes minutes of the meeting. We're going to determine from these meetings which ones had conflict. We're going to also determine, using sentiment analytics, that's part of behavioral analytics, the commonalities of behavior of the participants where there was conflict. In other words, for example, it starts 87.9% of the time it starts with a difference of opinion. The other 13% of conflict started before they got to the meeting, or something like that. Then we're going to use sentiment analysis again, analytics, to say, of those, we're talking about hundreds and hundreds of meetings. This is a global organization. And they're talking about one of the APAC division. So lots of sites and lots of meetings. So in addition to just finding out where the conflict might arise, how many of these diffused the conflict? It started with a difference of opinion, but it didn't get to conflict. Now we have an idea of the difference between those things that escalated into conflict taking out of the meeting and those things that were diffused. We identify those differences. Now, we're saying we here, but we're talking about the model will do this. Okay? What happened in the meetings that did not result in conflict that happened in the meetings that didn't happen in the meetings that did? What didn't happen in the meetings that didn't have conflict that did happen in the meetings that did? How do we know? Now we have some concrete steps that in 85% of the time, if you follow these steps, you will avoid conflict. Now, we're going to test the model against the training data. And then we'll expand the venue through the test data, and then we'll just let it run from then on, modifying it, and then we'll put out the results to everybody. Now, one of the things we ran into is that we wanted to record all of the meetings, so we have the data to work with. And so there was the message came up, this meeting is being recorded for training purposes. And of course it was training, but we were training the model, not the people. The problem is that when people know they're being observed, even only audibly observed, their behavior changes. And we were able to see that. The model, in fact, flagged it. When they knew they were being recorded, they acted differently, at least at the beginning. Fortunately, after a while, they didn't. Unfortunately, most of the conflict tended to start at the beginnings of the meetings, early on. So we found that was kind of muddying the data we had. And who found that out? Who pointed it out? The business analyst who was working on this, who helped put together this model. The model at the end would be able to predict the difference of opinion and commonalities of behavior, so that we could see what could be done to avoid, what the characteristics are of conflict, so that, if there are people who are constantly in conflict, we don't put them in the same meeting. In fact, we don't put them on the same project. And you can do this without highlighting the fact that Charlie and Fred are always in conflict. So you guys got to, settle your differences. No, you just don't put them in the same meeting. And then we validate the predictions. We predict that this meeting will result in conflict. And then we wait till the meeting's over and then find out, was there a conflict there? If there was, we proved the prediction. This meeting will not have conflict. Everyone's happy and they're all singing Kumbaya when they leave the meeting. Cool. If they're correct, We now know what to do. Yeah. You say, well, there's no code there. There's nothing, it's just kind of a highlight. That describes a data model. And when you're working in data analytics, that's the kind of model you're going to create. This is wonderful, especially if you really don't like diagrams a whole lot. So, to wrap up, what's the future of data modeling? We're going to say goodbye to traditional data modeling, if we ever said hello in the first place, but we're not going to be dealing with it. Entity models are great. They're best left to the data administrators. Sure, let them handle it. The class diagrams, the developers will do the class diagrams. They may ask us questions, we'll give them answers, and they go and draw the pictures. We do want static data models. We want them so we know the references to existing, especially transactional systems, and the data warehouse. We're going to say hello to data analytics models. Identify data sources for solutions. Define the quality of the data we need to do to achieve that quality. We're going to describe the algorithmic process to get the answer or the solution, just like we did in the previous page. You can't get far enough away. If you went to the developers and said, I want you to come up with a system that will handle conflict, they would laugh at you. Hey, this is not data. But that's what we just did. And that project, incidentally, is ongoing. It has not completed yet. And, of course, we're going to, as business analysts, confirm the results and ensure that, in fact, the problem was solved. With that, I'm going to turn it back to Tracy, who will read the questions that I can't read with these old eyes, and I'll hopefully give you some answers.
Thank you, Steve. Thanks again for such a great presentation. As a reminder, if you have any questions, please type your questions into the questions box. And Steve, right now we don't have any questions, so let's give everyone a moment. For those that are asking, yes, this session is being recorded and it's going to be posted to the MA website, our ModernAnalyst.com website, within a couple of business days. It's also going to have a link to the PowerPoint slides and the recording. And again, if you have any questions, just find the questions box on the GoToWebinar control panel and tap your questions into it. Now, Steve, here we go. As always, everyone's typing their questions in. Okay, you're getting some comments, Steve. I'll read this one. From an old admirer, does Steve still blush in his affable Southern manner when he's deemed the godfather of business analysis?
Yes, I do. From the top of my head down to my toes.
Excellent. And that was from Ron. I'll just leave it as that. Our next question here, how do you get AI without under 85% without human intervention?
Under 85%. I'm not sure what.
I'm so sorry. I read that wrong. My eyes. Greater than 85% without human intervention.
One word. Repetition. You're going to do it over and over again. You want to build muscle and get a certain circumference of your arm or something, your triceps. You do push-ups. One round of push-ups isn't going to do it, so you keep doing it over and over again until you build it up. Just like anything else you want to do, you do it. The more you do it, the better you become at it. So this is software, and the software is going to learn the same way. That's the way we use our intelligence to learn. So artificial intelligence does it the same way. By doing it again, by finding out what it did wrong, and then correcting what it did wrong, it gets more accurate. And we keep doing that over and over again, and we get more and more accurate. It will not stop until it feels that it is at the full accuracy. Now, we're not going to let the machine learning go off all by itself. We're going to stay there and control it. Like the chat GPT out there who that comes up with accusing a professor of plagiarism when the professor didn't do it, and so forth. And telling a reporter in the New York Times that the Chat GPT, the AI, is in love with the professor, and the reporter, and the reporter ought to leave his wife and run off with the machine learning software. We need a human being in there to provide the correction. And in this case, it usually is the data. Now, the machine doesn't know anything, whether it's good data or bad data. It doesn't know. We have to say, no, don't listen to that data. So the answer, I made it into a long one after telling you it was one word. The answer to becoming 85% or greater accuracy is repetition. Correct what you did wrong and do it again.
Thank you, Steve. I hate to throw this at you, but maybe you can answer it. And again, Mabel says, nice webinar, but also where can they get a bit more into the weeds to learn how to incorporate this in their day-to-day life as a BA? I'm not sure if you have any advice off the top of your head for that.
Well, if your organization is using machine learning, artificial intelligence, most likely you'll find out about it. It's not something they'll hide. When people are using it, they're talking about it. And if they are, find out where it is and go ask questions. Beyond that, there are books and other sources that will help you understand it more. I don't know how deeply in the weeds you want to get. For example, learning Python or R language, both of which I had some, I played with long after I gave up programming, but I wanted to see what they were like, and it was cool, kind of fun. Or just drop me a line if you want to be a little more specific. You can drop me a line. My email address is right there on the screen, and I'll be more than happy. I'm officially in semi-retirement here in Florida, so I'll be more than happy to respond to you and see if I can give you some help on that.
Thank you, Steve, and thank you. Kevin asked the previous question about greater than, and I think this is a follow-up question. Kevin, let me know if I'm not getting this correctly. Your comment or question was that, does that mean improve the training data / model?
Good question. I think I mentioned it, but I may not have, or I may have glossed over it. When we're going to review and say the fraud, we'll use that fraud as an example. We've looked at the fraud, and there were 20 frauds that it found out of a potential 30. And it found 2 others that we didn't think were frauds. Now we look at it and we say, okay, what we have to do, the model is not looking for these things clearly. So it didn't pick up these other 10. But it picked up these 2. And we look at the data and say, they shouldn't be there. There's data in there that's incorrect. So we're going to adjust the data in the training data. And then we're obviously going to go in and adjust the code that we wrote to identify the other 10. So the answer is both. The result might be changing the data. It's less likely, but that happens, especially in the training data when we first start out, because we'll make mistakes and we won't see things in the data. Many times, instead of changing the data, we change our expectations. Oh, the model came up with 2 more frauds, and son of a gun, they are frauds. We didn't see those. We overlooked them. Okay, so there are 32 frauds out there instead of 30. So we change our expectations. The code is where the changes are usually made. Now, once you get past the training data, it's a rare thing to change the test, and obviously you don't change the data in real life. After that, you may adjust the code. But in the training data, yeah, it's very possible we might redo the whole training data if it doesn't come out right the way we want.
Thank you.
And machine learning will do both also. It will actually change the data and itself.
Excellent, Steve, and thank you. That is all the questions and all the time we have for today. So again, thanks so much, Steve, for sharing your knowledge and expertise with us. We'd also like to thank everyone again for attending today's Modern Analyst webinar. Oh, I'd like to remind everyone that today's webinar, along with the slides, will be archived at the ModernAnalyst.com website within 2 business days. And so this concludes today's event. Again, Steve, thank you so much, and we hope everyone has a great rest of their day.
Thank you all.